Liam had been lied to, not the dramatic kind of lie, not the kind anyone admits to. The quiet kind that gets built into permit offices and contractor quotes and zoning ordinances, until it stops feeling like a lie and starts feeling like just the way things are. He had land, 40 acres outside of Fairbanks, paid for, his name on the deed, and for 3 years he could not put a roof on it without the system eating him alive. Permit fees, engineering sign-offs, frost depth foundation requirements that added $40,000 before a single wall went up, contractors who quoted him figures that assumed he had no other options and was too tired to look for any. He was not too tired. He just had not found the right door, yet that changed in October, when Marcus called. Marcus was not a builder by trade. He was a mechanic who had grown up in the valley, owned land adjacent to Liam's parcel, and had a particular kind of stubbornness that tended to produce either disaster or genius depending on the situation. He told Liam over the phone that he had been living full-time in a structure he built himself on his property for 7 months. He had not pulled a residential building permit, not because he had hidden anything or cut corners on the paperwork, because the structure he built did not legally require one. Liam drove out the next morning. What he found sitting in a clearing at the edge of Marcus's property was not what he expected. He had imagined something provisional, a large shed dressed up with curtains, something a man talks himself into calling a home because the alternative is admitting defeat. What he found instead was a building with a presence, a steel arch form, 30 feet wide at the base, curving up to a peak maybe 12 feet overhead, clad in interlocking rib panels that caught the early light and threw it back clean. The front face was almost entirely glass, floor to ceiling, arched to match the curve of the building itself. Framed in steel with a central door that opened into a space that was warm and lit and smelled like coffee and pine. Orange LED strips ran along the exterior ribs of the arch, against the blue of an Alaskan morning with 2 inches of new snow on the ground. The effect was not subtle. The building looked like it had been designed, thought about, built to be exactly what it was. Marcus waved him in from the doorway before Liam had finished processing what he was looking at. Inside, polished concrete floors, warm underfoot from radiant heat below. Wood panel walls following the interior curve of the arch. A small kitchen on one wall. A sleeping loft accessed by a fixed staircase at the rear. A wood stove burning on a tile hearth in the center of the main room, visible through the front glass from 20 yards away. The ceiling rose to 12 feet at the peak and then curved back down on both sides, creating a sense of enclosure that was nothing like a conventional rectangular room. Liam sat down and did not say anything for a while. Then he said, "Tell me about the permit." Here is what most people do not know. And the reason most people do not know, it is not complicated. It is simply that the building industry, contractors, engineers, permit offices, the entire professional apparatus that sits between you and a roof over your head, has no financial interest in telling you. Building codes were written with a specific assumption baked into them. The assumption is that anyone building a permanent structure will use wood framing, poured concrete foundations, and conventional roof trusses. That is the model the permit thresholds were designed around. The checklist exists for that model. The fee schedule exists for that model. The mandatory engineering review exists for that model. The Quonset arch is not that model. It has no load-bearing walls. It has no roof trusses. It does not require a poured foundation with frost-depth excavation. The arch itself carries all structural loads and compression, transferring force down the curve and into the base without the bending stress that conventional framing creates, and that conventional engineering sign-offs exist to verify. The structure is inherently stable in a way that wood framing is not, which is why the arch form has survived in human construction for over 2,000 years, while individual stick-built houses rarely outlast their mortgages. Because the Quonset arch does not match the model that building codes were written around, it frequently does not trigger the same permit requirements. In the Fairbanks North Star Borough and large areas of the Mat-Su Valley, structures classified as agricultural buildings, storage buildings, or accessory structures, which Quonset arch buildings often qualify as, depending on their footprint and how the permit office classifies them, either require no building permit at all or require only a simplified administrative approval that takes days rather than months. This is not a loophole in the dishonest sense. It is not fraud. It is a function of how language works in legislation, and what happens when new construction methods encounter regulations written for old ones. The gap is real. It has always been real. The building industry simply does not advertise it, because the building industry gets paid to manage complexity, and the Quonset arch eliminates most of the complexity they get paid to manage. Marcus had not stumbled into this accidentally. He had done the work, called the borough office twice, spoken directly with a permit technician, gotten a written response, in writing with a case number, confirming that a structure as described did not require a residential building permit under current ordinance. That written confirmation was sitting on his kitchen counter in a folder. He handed it to Liam before Liam thought to ask. That piece of paper was the most important document Liam had seen in 3 years of trying to build on his land. Over the next 6 weeks, Liam did what he always did when something felt important, and he did not fully understand it yet. He went deep. He drove to 3 other properties in the region where arch-style structures had been built in the past few years. He talked to the people living in them, asked the questions that mattered. How does it perform in January? What did it actually cost? What would you do differently? He spent hours on the phone with manufacturers in Oregon and the Midwest who had been producing prefabricated arch building kits for decades. He joined online forums where off-grid builders and rural landowners in Alaska, the Yukon, and northern Canada talked openly about what worked and what did not. He also read borough ordinances, zoning codes, the specific language in the permit threshold definitions. He read them the way you read a contract when something important is at stake, which means slowly, looking for the exact words, not the general impression. What he found confirmed everything Marcus had told him, and added a layer of technical understanding that changed how he thought about the whole question. The arch form works because of physics, not because of marketing. When you load a true arch, the forces resolve in pure compression. There is no bending moment, no tension failure, no weak point at mid-span. This is why Roman aqueducts built 2,000 years ago still carry water. It is why the arch kept appearing in bridges, cathedrals, and grain storage buildings across every civilization that ever needed to shelter a large space from the elements. The structural principle does not expire. In Alaska specifically, this matters in ways it does not matter in milder climates. Snow loads in the interior routinely exceed 60 pounds per square foot on a flat or low-slope roof. That is a number that kills stick-built structures. Undersized framing members, inadequate connections, ice dams that form when insulation fails, and create uneven melt patterns that back water under shingles and into wall cavities. An arch sheds snow by geometry. The load travels down the curve and into the foundation. There is no horizontal span fighting gravity the way a conventional rafter does. The structure does not weaken under load. It tightens. The steel is cold-formed galvanized rib panel with a coating system designed for freeze-thaw cycling and the kind of UV and moisture exposure that destroys painted wood and fiber cement cladding within a decade in northern climates. The panels interlock along their edges, creating a continuous weather-tight envelope without the thermal bridging that turns every stud in a stick-framed wall into a path for heat to escape. Apply 2 inches of closed-cell spray foam to the interior surface of those panels, and you get an air barrier and a thermal break in a single step, with R values that match or exceed conventional wall assemblies at a lower installed cost per square foot. Liam was not an engineer, but he had worked around construction long enough to know the difference between technical language that means something and technical language that exists to sell a product. This meant something. He chose a kit from an Oregon manufacturer with more than 30 years of production history, 30 foot wide, 42 feet long, just under 1,300 square feet of floor area. The kit included all the steel arch panels numbered in sequence, the base angle components, the assembly hardware, and the end wall framing systems for both the front glass face and the rear closed panel. Delivered to Fairbanks by freight, $27,800. He set that number next to the number a local contractor had quoted him for a 1,200 square foot stick-built cabin, $140,000. That quote did not include the foundation. It did not include mechanical systems. It did not include kitchen or bathroom finishes. The kit was not a finished cabin either, but it was a weather-tight shell he could finish himself, and the starting figure was 1/5 of what the conventional path would have cost before he touched a single interior wall. He called his brother-in-law, who worked in commercial construction and could read a structural drawing without needing an explanation. They spent an afternoon going through the assembly manual on video call. The panels were numbered. The sequence was logical. The base connection was the precision-critical step. Get the anchor bolts set correctly and everything above them followed. 2 or 3 people. 5 days under reasonable conditions, weathertight shell. His brother-in-law's verdict was 4 words. This is pretty simple. Liam broke frozen ground in late March. Not metaphorically. Literally broke frozen Alaskan ground with a rented excavator to prepare the perimeter gravel pad that would serve as his foundation. No frost-depth concrete pour. No poured-in-place footings requiring a foundation permit. A compacted gravel pad with embedded anchor bolts. Common practice in Alaskan outbuilding construction, specifically permitted under the Borough Code, without triggering the residential foundation requirements that would have added months and tens of thousands of dollars to project. He spent 2 days with a rented plate compactor, getting the pad level and compacted to the manufacturer's specification. He was precise about it because his brother-in-law had been clear. This was the step that mattered most. Everything that went up on top of an unlevel, undercompacted pad would reflect that error for the life of the building. The kit arrived on a flatbed in late April. He and his brother-in-law and a friend named Dale, who had helped construct 3 other buildings in the valley and had useful opinions about most things, unloaded the pallets with a rented telehandler and started laying out the base angle components the same afternoon. The first arch took most of day 1, not because it was complicated, because getting the base connections aligned before tightening required the kind of patience that cannot be rushed. Once that first arch was plumb and level and locked, the rest moved quickly. Day 3, full shelf standing. Day 5, front glass wall framed, rear end panel closed, structure weathertight. Liam stood at the front of the building on the evening of day 5 and looked at what existed now that had not existed a week earlier. The steel arch rose above him in a clean curve. The rib panels caught the low angle of the evening sun and threw warm light across the snow. It looked like a building that would be there in 50 years. It looked like something a person had meant to build. Interior work ran through the summer. Long Alaskan summer days that gave him light until 10 at night and let him work hours that would be impossible anywhere else. 2 inches of closed cell foam sprayed directly to the interior of the arch panels. Interior stud walls built inside the foam layer. Pine tongue and groove paneling milled locally and applied to those walls. The floor was the most labor-intensive component. A concrete slab poured over rigid foam insulation with PX tubing embedded for radiant heat, connected to a propane boiler in a small mechanical room he built into the rear section of the building. The radiant floor was a decision that cost the most and changed the building the most. Every other upgrade he made was structural or aesthetic. The radiant floor was experiential. You cannot understand what a warm floor does to a cold climate interior until you have lived one through an Alaskan January. There are no cold corners. There are no drafts at foot level. The heat is even and silent and constant, and it changes what the building feels like at 2 in the morning when the outside temperature has been below 0 for 6 consecutive days. He added a wood stove on a tile hearth in the main living area. Secondary heat source, aesthetic centerpiece, visible through the glass front wall from outside. The kitchen was propane range, propane refrigerator, stainless farmhouse sink, local cabinetry. The bathroom in the rear corner had a composting toilet, an on-demand propane water heater, and a proper tiled shower. The sleeping loft above the bathroom used the arch curve as its ceiling and connected to the main floor by a fixed staircase rather than a ladder, because Liam had made that decision deliberately. He moved in on a Tuesday in late August, when the fireweed was at full bloom and the nights were just beginning to turn. Final cost, $67,400. Kit delivery, foundation, interior finishes, mechanical systems, windows, glass wall, every dollar of outside labor, 600 hours of his own time not counted. Also not counted, the permit fees, engineering review costs, contractor markup, and construction loan interest that a conventional build would have generated. Conservative estimate on those exclusions, $30,000 to $50,000 additional dollars. He owned the building free and clear. No mortgage, no lien, no contractor waiting on a final payment. Land is building his, ongoing costs limited to propane, electricity from a small solar and generator system, and property taxes on the land he had already owned for 3 years before a single wall went up. The timeline was a number that hit people hardest when he told them 5 months from kit purchase to move in. He had watched a neighbor spend 11 months waiting for a building permit on a conventional cabin. That cabin then took 18 additional months to build. 29 months from decision to occupancy at more than twice the cost with a mortgage attached. That first winter taught him the last thing he needed to know. When the temperatures outside dropped to -30 and held there for a week at a time, the radiant floor kept the interior at 68 degrees without straining the propane system. When the wood stove had been out for 5 hours and the outside temperature was -40, the interior was still 58 degrees. The foam-insulated steel shell held heat without the drafts and cold pockets that had plagued every conventionally constructed building he had ever lived in. The building performed, not on paper, not in a manufacturer's test environment, in the specific and unforgiving reality of an Alaskan interior winter, which is not great on a curve and does not care about marketing claims. By the following spring, people had started calling, not because Liam had told anyone to call, because Marcus had mentioned it to someone, and that person had mentioned it to someone. And in small communities, that is all it takes when someone has done something real that other people have been wanting to do and did not know was possible. He told everyone the same things, in the same order, because the order mattered. Research your specific jurisdiction before assuming anything. The permit question depends on local language, and local language varies. Get clarification in writing with a case number. Do not accept a phone call as documentation. Do not cut corners on the foundation preparation. The gravel pad is not glamorous and it is not fast, but it is a thing that determines whether the building is still level in 15 years. Every mistake made at the base gets amplified by everything built above it. Spend the money on closed cell foam, not fiberglass, not rock wool. Closed cell applied directly to the steel in a cold climate. The air barrier is as important as the R value, and closed cell gives you both in one application. Do not underestimate the interior work. The shell goes up in 5 days. The livable space takes as long as any other finished work, because finished work is finished work regardless of what shape the building is. And go look at one in person before you decide anything. Because the photographs, the dramatic arch glowing against the dark winter sky, the warm light through glass, the snow in the clearing, the photographs are not wrong, but they are not complete. The reality of being inside one of these buildings, of standing in a space that is warm and quiet and structurally honest and entirely yours, is something that does not fully transmit through a screen. The photographs make it look like a statement. The building itself feels like a solution. Liam walked out onto his deck on a morning in early April. Almost exactly 1 year from the morning, he had stood in the snow outside Marcus's window, not yet knowing what he was looking at. The sun was already up at 7, already doing real work. The spruce trees around the clearing were still. The snow on the ground was beginning to crust from the melt-freeze cycle that meant the season was turning. Behind him, the building was warm, solid, quiet in a way that well-built things are quiet, absorbing the morning rather than fighting it. It had cost him less than half of what a contractor would have charged. It had taken less than a year from first phone call to first winter inside it. It had performed exactly as it was supposed to perform in conditions that tested everything built in this latitude. He had land. He had a building on the land. Nobody had a lien on either one. He finished his coffee and went in to start the fire.